And now?
Yes, yes, we can see.
Okay. So the report presents a data mining analyzing of the ambulatory blood pressure monitoring database, which was published in 2017 and includes data from the 270 patients. The analysis involved processing, denoising, unsupervised machine learning, and feature selection using Java-based software, especially Becca 396. Four authors of this report are from Petromohila Black Sea National University and one from the Swansea University Medical School, United Kingdom. And three of these authors them present engineering department of Petromohila Black Sea National University, and the other two specialized at medicine. So ambulatory blood pressure monitoring has gained widespread recognition among clinicians, and available tools for hypertension diagnosis and management over the past 3 decades. ABPM involves continuous blood pressure measurements over a 24 hours period using a portable device. It provides critical information for diagnosing conditions like disguised hypertension, nocturnal hypertension, sustained hypertension, while also assisting in hypertension treatment. So the objectives of our report are aims to address the problem of data noise and enhance the ABPM dataset. The primary objectives include investigating the diagnostic value of different clinical classification levels in the predicting hypertension. Next one is performing clustering and assessing the congruence of clusters, the pre-selected levels. Selecting the most relevant attributes for reduce the dataset and emphasize clinically significant attributes. Keeping the clinical needs in mind by using machine learning software with user-friendly visual tools. In this case, in our case, it's a Becca, a Java-based software is employed. So primary data set consists of the data of 270 patients, including 159 women and 101 men, ranging from 14 to 93 years old. The data was collected by cardiologists at Central Hospitalier's cardiology department in Sétif, Algeria. The dataset includes various clinical outcome labels, each with a specific code and the number of positive and negative instances. You can see the label variability was considered redundant and removed, resulting in a reduced dataset with 185 individuals, and for clinical classification labels. The label variability becomes redundant with validity because both of them inherited in each of the 185 remaining instances of the reduced database. So the analysis of identified outliers and extreme values using an integrated range filter, which detected outliers in 18% of the instances. Additionally, of the correct analysis highlights noisy attributes, with pulse pressure and monitoring surge being the noisiest, while circadian rhythm and blood pressure load has minimal noise level. So co-appearance-based analysis was applied to identify questionable values for both nominal and numeric attributes. So about the clustering as unsupervised machine learning. Clustering analysis was performed using the three different algorithms: centroid-based, simple k-means, and cascade k-means, and the model-based, and neural networks-based. The clustering result indicated the presence of two clusters in the dataset. Recall that the four clinical classification levels following the Noisen were surgical rhythm, pulse pressure, monitoring surge, and blood pressure load. And the next one, the figure one, you can see the all of 5 algorithms forecasted to two clusters with capacities. Different clustering algorithms were applied, resulting in two structural clustering, minor from 56 to 84 instances, and larger from the 101 to 129 instances. The most congruent classification level was found to be the blood pressure load level, as indicated by high Falks-Mallow indexes. You can see on this slide the Falks-Mallow indexes for obtained cluster, the blood pressure load attribute. This is a cluster 1 and it's a positive, and cluster 1 it's a negative, and cluster 2 matches the positive one. So is it well known that noisy data reduce the FMI? Larger FMI values close to 1 indicate good congruence and acceptable noise. The FMI for the blood pressure load level was relatively high. The range was 0.758 to 0.98929. It should be noted that FMI looks much more modest for the circadian rhythm and other classification. In this slide, you can see feature selection and dataset reduction. So the eternal order inside the set matches the ranking of the attributes within the relief attribute evaluator with 0 threshold. One can see that BPS load day is a primary attribute of this set. The attributes absolute noise values are shown in this table too. The next one, it's figure 3. It's illustrated VECA histogram for a blood pressure load along the vertical axis and versus BPS 24 daily systolic blood pressure. The range BPS 24 was from 102 to 213 millimeter Ag, is divided into 9 bins, different colors, labeled 2 classes, blue and red, and missed values labeled black colors. So let's go to the conclusion and future work direction of our report. The main conclusion of the study include the recognition of the ABPM database noise and the identification of the blood pressure load level and as the optimal classification class. The report suggests the future work should focus on additional levers for a classification and using methods to handle missing values and numeric attributes. So the report provides our detailed overview of data mining analysis conducting on the ABPM database, addressing database noise, clustering, future selection, and dataset reduction. The insights gained from this analysis can be evaluable for clinicians and researchers in the field of hypertension management and diagnosis. So thank you for a good opportunity to be here, and thank you for attention and interest.
Thank you very much. It is very interesting report. Thank you very much. Dear colleagues, have a question? Sorry, I have some question. My question is probably a standard one of medical topics. What is the reliability of the obtained results? How was the validity of the results of the study assessed?
So the results of the our researching is we are investigated ABPM database like valid 68.5%. This result characterized the validity of data and the lowest noisy of this was like blood pressure load, the lowest level. I can hear you.
Sorry. I mute.
Yeah, microphone.
Sorry, dear colleagues, have a question? Have a question? Thank you very much. Olga, thank you very much.